everyone, Mrs. Below here. In this video, I'm just going to be breaking down this video a little bit more to help you understand how energy is conserved in a chemical reaction.
Where does all this stuff come from? This rock, that cow, your heart. Not the things themselves, mind you, but what they're made of, the atoms that are the fabric of all things. To answer that question, we look to the law of conservation of mass. This law says, take an isolated system, defined by a boundary that matter and energy cannot cross. Inside this system, mass, aka matter and energy, can neither be created nor destroyed. The universe.
So the law of conservation of mass and the law of conservation of energy both basically say the same thing. The law of conservation of mass is saying mass cannot be created or destroyed, and the law of conservation of energy is saying that energy cannot be created or destroyed. And you do not have to talk about this in your presentation, but when he says like energy and mass are the same thing, kind of, it's referring to Einstein's equation E equals mc squared, which you do not have to talk about in your presentation.
First, to the best of our knowledge, is an isolated system. But before we get to that, let's look at a much smaller and simpler one. Here we have 6 carbon atoms, 12 hydrogen atoms, and 18 oxygen atoms. With a little energy, our molecules can really get moving.
So this reaction that he's talking about is actually photosynthesis. He doesn't say that, but that energy that he showed, that energy is coming from the sun. That is sunlight energy or solar energy. That's where that energy is coming from, that's being used in this chemical reaction.
These atoms can bond together to form familiar molecules. Here's water, and here's carbon dioxide. We can't create or destroy mass. We're stuck with what we've got. So what can we do? They have a mind of their own. Let's see. They've formed more carbon dioxide and water, 6 of each. Add a little energy.
So again, that energy that he's talking about is coming from the sun. There's also energy that is stored in the chemical bonds of all molecules that are bonded together. So when you have elements that bond together, atoms that bond together to form molecules like these guys, there is energy stored in their bonds.
And we can get them to reshuffle themselves to a simple sugar and some oxygen gas. Our atoms are all accounted for, 6 carbon.
So you're probably wondering, where did that energy go? And that energy from the sun, it gets stored in the bonds of those molecules.
12 hydrogen and 18 oxygen. The energy we applied is now stored in the bonds between atoms.
So that's an example of the law of conservation of energy. Basically, energy is just changing forms. And in this case, we're changing it from like energy that we're getting from the sun, and we're changing it into chemical energy, which is being stored in the bonds of these new molecules.
We can re-release that energy by breaking that sugar back in.
Right, and so if you want to access that energy, you can break those bonds to access that energy.
To water and carbon dioxide, and still, same atoms. Let's put a few of our atoms aside and try something a little more explosive. This here is methane, most commonly associated with cow flatulence, but also used for rocket fuel. If we add some oxygen and a little bit of energy.
So that energy is coming from the match.
Like you might get from a lit match, it combusts into carbon dioxide, water, and even more energy.
And so energy is just changing forms. You have it in heat in the match, and then when it combines with methane, you get basically an explosion, and you have a large release of even more heat and energy.
Notice, our methane started with 4 hydrogen, and at the end, we still have 4 hydrogen, captured in 2 water molecules. For a grand finale, here's propane, another combustible gas. We add oxygen, light it up, and boom, more water and carbon dioxide. This time we get 3 CO2s, because the propane molecule started with 3 carbon atoms, and they have nowhere else to go.
So again, it's very clear to see how the mass is being conserved, because those are those atoms that you're seeing, how they're just being rearranged in a chemical reaction. And in terms of the energy, that energy is still being conserved. You still have energy, for the same amount from when you start to when you end. It just might be changing forms as well. Maybe from that match in the form of heat, and then, into a large release of energy in like an explosion.
There are many other reactions we can model with this small set of atoms, and the law of conservation of mass always holds true. Whatever matter and energy go into a chemical reaction are present and accounted for when it's complete.
So again, this was the first one he mentioned in the video. So that energy that he's talking about here is coming from sunlight. So we're taking that solar energy and we're changing it into chemical energy that's now stored in the bonds of those atoms, or molecules, if you will.